All right, so let's continue this discussion. Here's a quick overview. So in the CSV file, there are descriptions. And remember, the CSV file has a format: point number, northing, easting, elevation, description. So this description is the form T dash and then some description, right? Ground, CL for center line, shoulder, edge of pavement, and so on. So this description from the CSV file is what we're going to use to manage some of the information in the drawing. We use what's called a description key to put the layer, to put the points on the layer. So if your description from here is T dash, the description key will put it on a layer called P dash, right? Some P dash layer. So if your description is T dash CL, the description key function will put it on a layer called P dash CL, and so on. Okay, so you have to make sure that happens. That's how we manage the points, by putting the same description on the same layer instead of all on one layer. So that's one thing we talked about. The other thing we looked at are groups, point groups, and each group has point styles, and point label style. So if you're a member of this group, this is what your point will look like. This is what your label will look like. How do you gain membership into the group? Well, again, based on your T dash description from the CSV file, you will belong to a group called G dash something. That's the name of the group. So if you're a T dash tree, you go into a group called G dash tree. And how do you gain membership into the group? Again, by the description, right? And so typically we use the asterisk, T dash something asterisk. And in the description key, we use the T dash description with an asterisk at the beginning and at the end. So the description key is looking for this from this file and putting it on this layer. The group is now looking for this description and putting it into this group. And then what will you look like? Well, whatever group you're a member of. So that's the other thing we did. Okay, so programming your description key, I believe, was document number 1. Creating point styles and point label styles was document number 2. Creating point groups is document number 3. And then finally, importing the points, making use of all that. Okay. Now, I've had some students email me and ask me questions. Oh, I did it and it didn't work. Okay. You have to follow the instructions exactly. A couple of things to be mindful of is it might be case sensitive. Sensitive. If I can spell right, sensitive. So you have to put an uppercase T, not a lowercase t. Make sure you spell it. Spelling is critical. It has to be exactly. Whatever is in this file, you have to duplicate it, right? And what I do to prevent problems, there's just a tip. Instead of typing in the name, I can copy and paste the text string into the field I want. So instead of typing T-CL, I'll actually just take it right out of the CSV file, copy the text string, paste it into the description key. Copy the text string, paste it into the include tab for the group. Okay, so that's one way of minimizing spelling errors, if you just copy and paste what you see as opposed to trying to retype it. Okay, that's been a handy hint in the past. And then when you import the points, everything should happen at once. The description key, if it's on, will put everything on the appropriate layer. And if your groups with the assigned point styles and point label styles are ready, then the points will go into the group and look like the group settings. Then there's some layer control, colors and line types for the layers. That's the last thing I would do. Okay, that really doesn't matter at this point, but it's something obviously you have to have done for the assignment. Don't create any layers until the end, because some of the layers you create them during the description key. So if you don't have the P- layers, you create them during the programming of the description key. When you import the DXF file, when you import that DXF file, you'll get the T- layers. And this is confusing. When you import the DXF file, it's going to create T- layers. This is for the lines, the line work. And the T- layers, the layer for the line, this is where it gets confusing. If your description as a point is T-, you go on a layer P-. The points go on a P layer. The lines that connects the points goes on a T- layer. So this is a layer for lines. These are the layers for points. T- for lines, P- for points. And it's a bit confusing. Why don't you use T dash for and so on? This is the description in the CSV file. This is the layer in AutoCAD. This is the layer in AutoCAD. This is for points. This is for lines. Okay? So just a brief overview of the concept. Okay? Doing all the details is in the PDFs. Okay? They're pretty handy. Some of them might be out of date with the number of items you have to do, so you really have to pay attention to the data I'm providing. But once you do one thing, you can quickly go on and repeat it. Okay? There's a lot of repetition, so you get a lot of practice with some of this stuff. Okay, so at this point here, if you did the work that I assigned, you should have all your points imported on the correct layer in the correct group with all the proper styles and settings. Okay, so let's take a quick look at that. I'm going to share now my AutoCAD Civil 3D. Okay, so you should see my CAD screen. I just don't know why it's not coming up. Doesn't look like it's showing. Okay, let me try something else. Show my entire screen, allow. You're going to see kind of this infinite effect. Yeah, okay. And then when I bring in my, okay, can everybody see my AutoCAD screen? Yeah, I think you can. Yes, okay. I'm going to try and put it over here so I can talk to you. Actually, let's use the audio. So if you have a question, answer. If I ask a question or you have a question, use the audio setting, okay? Please stay muted until you have something to say, okay? So if you brought in everything with the description key, right, then if you isolate one of the layers, like the center line or the edge of pavement, you can see they're on separate layers. That's a result of the description key. And then if you have point groups, I only created one. If you're in this group, so if you go to point groups, right-click properties, how do you gain membership into the group? Well, you go to the include tab and make sure you put the description here. And if you really want to make sure, put in an asterisk at the beginning and at the end of the description. Remember, this is what shows up in the CSV file, right? The description of the point. If this is your description, you're a member of this group. If you're a member of this group, this is what you're going to look like. Okay? You're going to look like a tree, and you're going to have elevation only. Okay? That's not what I asked you in the assignment. I'm just giving this as an example. So if you zoom in, you'll see it looks like a tree, and it only has an elevation. Okay? So you get a lot of drafting done, right? If you can apply symbols to the points with the proper label, you can quickly see that you get a lot of drafting done for free by managing your point groups. So for each point group, you'll have a different thing. There's another one here. I think there's one called. Sorry, are people asking questions? Can I use other methods to include it? You can, but this is probably the most popular one. You could use point number range. There's many options. Let me show you. So if I go to a point group and I right-click properties, instead of in the include tab, you can just match numbers. So then you can select which points are a member of this group, and then it'll keep track of the point number, which is unique. But the best way is the description. If this is your description, put it in here. Okay, that's all I really want you to know. That's probably the most fundamental way of doing it. But there are other ways, right? You can have elevations, greater than, less than, or certain values, and so on. So there's more than one way. Okay. Again, if you wanted to do, let me see if they're here. I believe there's. If I go by name, hang on a second. Let me just see. I believe that was it. Okay. All right. So if you wanted to see those, you could then program each one. The assignment, I believe. Let me just check it. The assignment. Oh, sorry, my phone's ringing. Apologize. Sorry about that.
Professor, I think you're muted.
Thanks for that. Sorry. It's still muted? Hello? Can you hear me? Oh, okay. Sorry about that. So if you wanted to create the hydrant look, again, you can go create the style. So just, again, a quick overview. Some people were asking me all these questions on email. So I just wanted to give an example. Like I said, I didn't do all of them. I gave some examples. But if you go to settings, under point styles, start with the standard one. Always make a copy of it. Call it hydrant. And then the marker is going to be an AutoCAD one called hydrant. So it looks like a hydrant, whatever that symbol is. And I believe the size, let's just check the size, is going to be 1.5. Say OK. And now you have a style. So if you want the hydrant to look like a hydrant, you go back to the point group for hydrant, right-click properties, and change the style to hydrant, and say OK. And now it looks like a hydrant. So you can do a lot of drafting. If you were doing this just with some of the AutoCAD skills you have up till this point, you would create a block, find all those points, and insert a block at each location, right? And that's very painful. So with this database, you can manage the look of the different items very quickly, right? And now all the hydrants look like that. If there's others, and I believe there are, yeah, all the hydrants look like that. Oh, you don't like that symbol? Change it. So the order in which I gave you to do the stuff is really important, right? Create your description keys so that the import puts everything on separate layers. Create all your styles so that when you create the groups, you can assign the styles for point and point label. And then when you import the points, everything should happen. Should go onto the correct layer, go into the correct group, okay? You can manage the colors and line types of the layers at the end before you submit, before you get that. That's kind of a trivial thing to do. Okay? Any questions about that? A bit of a review. Okay, again, I'm not doing everything. I'm just giving examples of what you're going to be doing or seeing when you do your work. Okay. The next step is to import the points. I can do that again. I'll show you. Okay, I'm just going to erase all the points. Don't do this. Okay, I just want you to see the effect. Again, I'm going to go to points, create points. I use this pull down menu. It's the last button on the right. And again, make sure the settings are correct. This is in the file, the point creation. You want to turn your description key to false and make sure that your default styles are set to none. Okay, the word none here for both point label and point style, instead of the word none, a better word would be by group. If I'm a member of this group, this is what I look like. You don't want to hard code this. Remember items like lines and text? The color should be by layer. The line type should be by layer. And then you can globally manage the color and the line type of anything on that item, on that layer by changing the layer settings. The groups work much the same way. But any item that's a member of that group has to have the point style and the point label style to set to none, which is really to say by group. Okay? The language is a little bit silly, but that's how it works. So that's why I'm here to help you with that. Okay. Another thing you'll notice when I deleted the points over to the right, the left here, you'll see that little shield, that warning sign. That means, hey, something changed. What's going on? When you see a warning there on the point groups, okay, if you ever see that, right click, and you will see it on occasion when you make changes. If you right click on the groups, point group settings, just use the update button. And that's the digital equivalent of walking over to the computer and kicking it in the side, right? Hey, please behave. Okay, so right click, update. That's how you get it to kind of snap out of the problem. So let me import the points now. Okay, once those settings are ready. So import points, find the point file, CSV, whatever number is assigned to you. I'm using 00. Make sure the description is always PNEZD, comma delimited, and that's all you need to do. Say OK, and it imports the points. Your description key is working, puts everything on the correct layer. If all of your groups are ready, then everything will look the way it's supposed to, right? See that shield again there? When you see that warning, right click, and it'll happen automatically. Watch here. See the trees? Right click, update, and they snap out of it. Then they look like the group they're a member of, okay? So that's what I expected you to have done to start today's class, okay? If you haven't got far, you're a little bit behind in terms of my pace. but certainly there's plenty of time before this is due. Remember, on Friday. Okay, this assignment's due Friday. So there are now. So we did 4. Now we want to create a surface and then surface style. So there's 2 more steps and then some AutoCAD housekeeping stuff. How do you create a surface? When it comes to surfaces, I'm just erasing my whiteboard. When it comes to surfaces, there's basic information that you have to give it. One of the things I talked about last day was to import the break lines, and that's in file number 5, create the surface. One of the things it tells you is import the file called, it's not called break lines, it's called, it's that DXF file, right? So it says here to insert the break lines DXF. That's more of a description. That's not the name of the file. The name of the file is the name of the file is this, 2D Topo 2020. Okay, so that's a little bit out of date. So to insert that or to import that, I gave a warning. Remember, if you insert it and it doesn't come in the right spot, right? So if you go to insert that file, and if you don't see the file, make sure the file type is DXF, not DWG. If it says DWG, you won't see it, even though you're in the right folder. So make sure it's DXF, and you should see it. When you say open, and you double click to bring it in, I'm going to redefine the block. It should fall right into place. Okay, now if you didn't do it, and I'm going to redo this, make sure before you double click, you turn everything off. You want to use the defaults. 0, 0, 0 is the insertion point, scale of 1 across the board, angle 0. Okay, leave all of that as the defaults. And if you double click, it should come right in. If it doesn't fall exactly where the points came in, remember last day when I did it, it kind of went down here because it converted from feet to meters or meters to feet. If you have that problem, which you will, and I kind of, this happened by accident, but it's a good thing to learn. You have to open up the DXF file and change the DD units setting. DD units, and make sure this file is set to meters. So open up the other drawing, change it from feet to meters so that they both have the same settings. And then when you insert it, it should come in exactly where it's supposed to be. Okay, so try it. You could do the insert command once and see that it's in the wrong spot, and then undo that command or delete that information, and then go and change the setting in the other file and then come back and insert it. Okay, so it's a good learning moment. It caught me off guard. I forgot to change it when I created that file. Okay, so if you have that problem, just you have to have the DD units settings to meters in both files. Otherwise, it'll apply a scale factor of units. Okay, so here's the information that we received. Let me just turn off all the points. So I'm going to go to my layer control, find those P- layers. These are the layers with the points, and I'm going to turn those layers off. So these are the lines that I just inserted. Now these lines represent kind of connect the dots. You remember that exercise we did with the triangles? You know, the cross section, is it high in the middle? Is it low in the middle? When you create the surface just with points, it's going to triangulate and connect the dots based on a pure math principle. It's not rooted in reality. This information tells me, hey, all the points on the center line should be connected. And by the way, if it comes in and you forgot to explode it, you can explode it. You know, all the points on center should be connected. All the edges of pavement should be connected. All the edge of shoulder should be connected. The toe of slope, the top of slope, they should all be connected. And I'll show you, when I create the surface, they will not connect the dots according to this line. So you use these lines to form those relationships, okay? The thing that you don't want to use for break lines or fault lines is anything related to the servicing. These lines represent underground stuff, okay? So anything related to sand, storm, or water, and I'll show you those layers. If you go to the T- layers, these are the ones you get. So you don't have to create these layers. They come from the DXF file. Anything related to sanitary, SAN, I don't want. Anything related to storm, I don't want. And anything related to the water main, I don't want. These are underground items. There's no points. All the point data I have is surface features. So I'm going to turn those off so that they're not selected. Okay, so now they're all gone. So now all I have is edge of pavement, shoulder, the center line, edge of pavement, shoulder, embankment layers, top and toe of slope, and that's it. Okay, these are the break lines. How do I know? Well, let me turn on my point layers, and I'll show you exactly why I know these should be break lines. Let me turn on the center line of the road. If you zoom in on the road and you touch the polyline, you'll see the vertices are exactly where the points are. See that? If I move this here and I move this here, it connected the dots based on the points. So these lines actually were created from the points. Somebody connected the dots by whatever method, right? There's automated ways of doing it. There's manual ways of doing it, okay? In this case, they're provided, so we'll just use them. And if you bring in the edge of pavement layer, edge of pavement, you'll see that's true as well, right? All the points on the all the points are on the vertices of the polyline, okay? And when you list them, they're all flat, right? Zero elevation. So they're just 2D. Okay, but they do illustrate how the points should be connected when you do your triangulation. Okay, so let me turn on all, layers again, the point layers. Again, keep the sandstorm and water layers off. You don't want to select them as break lines. Okay, the other thing I'm going to do for the demonstration, I'm just going to make all of the lines layers red. It's wrong. On the assignment, I have different colors and different line types, but just for this, I want to make them red so that you can see them, okay? That's wrong. That's the wrong color. That's the wrong line type for all of them, okay? But I just want to make them red for the purpose of my next demonstration. So once you have all the points, and once you have all the lines that represents how the points should be connected, you've got two of the three things you need to build a surface, okay? You need points. You have to have X, Y, Z data. That's what the points give you. You have to have break lines if they're available. So these are provided. Okay, so anything that should be connected in sequence and you have lines for, you should use them to build the surface. Okay, and I'll show you the effect. I'm going to build the surface in steps, not all at once. I'll build it with just the points, then I'll show you what it does when you add the break lines, and I'll show you what it does when we add the last item. The third item typically is a boundary. Okay, and I'll show you how to create the geometry for the boundary. So let's just create a surface. So this is in the document, the PDF page. You go to this, so again, we'll start right from scratch. So you go to your tool space. You go to the surfaces, and notice there aren't any right now. You right click, you create a surface. In this dialog box, you give it a name. I'm going to call it existing. And I'm going to give it a style. There's only two styles. If you have more than two styles to select, then you use the wrong template when you created this file on step 0. Okay, so just be mindful. There should only be two options here. I'm just going to call it standard so that we see something. Okay, this is a style that shows the 3D tin lines, the triangle lines. Okay, so that when I create it, you'll see something. Say OK, and it creates this empty box. So that's a surface called existing, and there's no data, so you don't see the surface. If you expand this and you go to definition and expand that, you'll see options. These are, I'm not going to discuss all of them. I'm just going to give you the basics. Point groups, that's how we get the point data in. So I'm going to right click, add the point groups. So you should have a list of all the point group names, G dash this, G dash that, and so on. It's good practice to use just the groups G dash, and that's what I want you to do, okay? Do not assign all the points, because in a drawing, you might have points that you don't want to use, okay? For instance, if you're in a drawing where you have existing ground points and then you create some points for proposed ground, you don't want to have them all, you don't want to use everything in the drawing. So some you want to use and some you don't. So only use the G dash layers. Okay, so if there's a list of 10 G dash layers, you can click on the first one, use your shift key, and click on the last one, it'll all of them. Okay, I've only got 2, so you're not going to see much. I'm going to show you. Okay, so I'm going to say OK, and it creates a surface of just the items on that layer. So it connected the hydrants, right, because that's the group I have, and all the trees, right, which is wrong. It didn't include every other point because I don't have the groups ready for those. Okay, so I'm going to ask you to close your eyes for just a minute. I'm going to get rid of these groups. I'm going to delete it. And then I'm going to build my, see that warning symbol? Right click on surface, or right click on the word, the actual surface, and rebuild it. Or you can turn rebuild automatic on, and then any changes you make will automatically happen. So again, how do I get the points in? Point groups, add. Do what I say, don't do what I'm about to do. In this step here, you want to select the entire list of the G dash layers. Do not select this. That's the wrong thing to do. Okay? But that's what I'm going to do. So don't do what I do, do what I say. Right? It's in the instructions. So if you do that, you'll get this result, right? All the groups actually have all the points in it. So this is what you'll get. This is the surface that appears. So this is a surface made up strictly of the points, G dash group layers, or G dash groups points, okay? If you zoom in on the roads, you'll see the red lines? They're peeking through. Well, this is the computer's version of how the points should be related, how they should be connected. What I'd like to see is a cyan line right on top of all the red lines. And the way to do that is to define these as the relationships between the points. That's reality. What the computer's doing now with the relationship between the points is not reality. Sometimes it works out. So you can see here, the edge of pavement points, the center line, and the edge of pavement points, they actually are connected the way you want. But throughout, you'll see it's mostly not doing that. Okay? So remember, the sand, storm, and water T-dash layers are off. Only the planimetric stuff that should be used to connect the points should be on. So then you go back to the definition of the surface existing, go to the definition and go to break lines. If you right click, add, you're going to add break lines. Okay? A couple things to be mindful of here. You must change this to proximity. Okay? The default standard is not going to work for you. If you use the default standard, it's going to add more point data. And the point data it's going to get is the northing, easting, and elevation of all the polyline vertices, which in this case, remember, are all 0. Well, I don't want extra points that are 0. I don't want any points. I just want to say, hey, if there's a point at each end of this polyline or along the vertices, connect them in sequence. So to avoid getting more point data, which in this case would be wrong, I don't want 0 elevations, I'm going to use the proximity setting. Right? So this tells me how to connect the existing points, not to add more point data. So when you do that, so change that from standard, that's the default, change it to proximity, okay, zoom out and select everything in the drawing. It'll only select polylines. Okay? So make sure that the sandstorm and water layers are off. Watch what happens in the road here. Remember this? The red lines are peeking out, and this is happening throughout the whole drawing. Watch, I'm going to hit enter. It retriangulates. Now there are no red lines peeking out. It forced the relationship so that the points are connected in sequence. Okay? And what does that look like? Well, it makes sure that the model of the road is exactly what it's supposed to represent. Okay? Let me give you another view. Okay, what I'm going to show you now, you don't need to do. I'm just going to use it as a tool to demonstrate what I'm talking about. So I deleted the break lines. If I draw a polyline through here, I'm going to draw a cross section through the road. Sorry, somebody have a question? No? Okay. So I'm going to draw a cross section through the surface here. So what I'm about to show you is just for visualization purposes. You don't need to do this. Okay. So under profile, I'm going to create what's called a quick profile along here of the existing ground, and I'm going to put it here. Okay, and I'm going to change that to edit profile style. Oops. Okay, so here's what the cross section looks like right now. Okay, right across here. Okay, you can kind of see the ditch line here and the ditch line here. Let me just change the style of this too. Change this to road. Okay, so that's the cross section of the road. Watch what happens to that cross section when I add the break lines. Okay, it'll actually model it the way it's supposed to. So let me add this break lines, add. Again, proximity. I don't want extra points with 0 elevation. I'm just going to select everything, okay, except this polyline. Okay. Now, don't watch here, but watch the cross section. Now it looks like a cross section of a road. And if you see here, the center line, the edge of pavement, the edge of shoulder, and so on. That's more realistic. And that's what the break lines help you do. It helps you create a surface that will create the proper shape of the road. If you don't use break lines, then you're not going to get that. You're not going to get a true model. If your existing ground model, digital surface model, is incorrect, if it doesn't represent reality, then when you do design using the surface, which we will, you're not going to design the right thing. For instance, I need to design a road that connects to this edge of pavement. That's part of the subdivision design. Well, if that point right there is at the wrong elevation because the triangulation is wrong, then your design is all wrong. When you're doing earthworks calculations, right, volumes between two surfaces, well, if one of the surfaces is not realistic, then you're not going to get the proper volume for cost and quantities and so on. So that's what the break lines do. So I suggest you use them all, okay? Yeah, so add the point groups, add all the T-dash layers, except for sandstorm and water main. They're break lines, so that's step 2. And then the next thing you want to do is a boundary. Okay, now why do you want a boundary? Well, if you look at the, sorry, before I go on to boundary, any questions about that? So add the point groups, add the break lines. Okay. Oh, and by the way, there's some break lines that are missing. This is part of the assignment. Let me turn, I'm going to grab the surface, right click, go to surface properties and change the style. Let's make it no display. I don't want to see it. Okay, no display. There are some missing break lines. Remember, if certain points should be connected in sequence, then it'd be nice if we had a polyline there that I could use as a break line. There is one layer that's missing. So in the assignment, you're supposed to create a layer. I'm going to just do a quick demo. You're supposed to create a layer called T-watercourse. See P-? These are the points on the edge or the center of a water feature. I'm going to create a layer and I'm going to call it T-, and I'm going to make it current. And then just for demonstration purposes, I'm going to make it magenta. Okay? The color is on the assignment. Don't use magenta. So what I'm going to do is I'm going to turn off all the layers except the watercourse layer that's current and the P watercourse, the points for the watercourse. Watch what you see. You can kind of see a pattern of the watercourse. Okay? If you look here, this is kind of the center of a ditch, right? Or center of a stream. There's no break lines. We didn't get any. So we have to create them. So if you turn your OSNAP, whoops. If you turn your OSNAP to node, you can snap to the nodes. So I'm going to create a polyline and I'm going to connect the dots. Here's the center of the stream here, the center of the stream here. This should be used as a break line. I didn't get it, but I know it makes sense to connect the dots. This is the center line of the stream or the creek or whatever, this water course, all the way to here. Okay? So this actually flows, if you look at the elevation, 153.3, 152.9, it flows in this direction. So the low point's over here. This other Y shape, if you look at it, is actually got points together. Now watch what I'm going to do. I'm going to turn off. I'm going to get rid of the style for the label. Okay, so I'm going to go to my point groups. Now I don't have a group for the water course, so I'm just going to apply it to all the points. I'm going to turn off the style to none. So now I don't see the label. And now it's easy to see pairs of points. So if you were to look at a cross section here, it would look like this, a V bottom. If you look at a cross section through here, you'd see a trapezoidal bottom, 2 points, one on each side. Okay, so this line takes care of connecting all the dots down here. These two, if you connect the dots from here, and you connect the dots on the other side, those two lines represent these two bottom points on a water feature. Okay, in the break line, in the DXF file, these lines are not provided. So you as a user have to kind of go into the drawing and say, hey, you know, is there anything that maybe doesn't have a break line that maybe should? I'm going to create it myself. So the assignment requires that you draw these break lines. You have to draw all of them. I drew this one. You have to draw all of them, okay, and not just a few, right? You have to draw this double Y shape, okay, all the way along. So 2 double lines here, 2 double lines here, and then there's a junction. You got to figure out how to connect them in here. I'm going to leave that up to you. I'm not going to demonstrate this. Figure it out, right? I'm the boss. I'm asking you to do it. Let's see what you do. Okay, there's no wrong answer really. You have to interpret what you see and draw the double line on this Y-shaped figure. So that's in the instructions for the assignment. Okay, not the PDF guides, but it's in the assignment, right? This is a requirement for the assignment. So if there are missing break lines that should be there and you didn't get them, create them yourself. And that's the technique. Create a new layer, describes this. Create a layer called T watercourse, set it current, connect the dots for the P-watercourse layers. Okay, so I'm going to turn these back on. Standard. This is just a temporary way of getting rid of the labels so they're not in your face, right? But then you want to see that information. Any questions so far? So create more break lines. Okay, now if you've already added the break lines, If you've already added the break lines, and let me undo a few steps, get those lines back. Yeah, so if you've already added a few, sorry, let me do this again. And let me go back to the surface, bring it back as a style standard so that we see something, right? I just right click and change the surface properties, select a different style, standard style, region. Oh, you got to turn the layer that the surface is on. As a matter of fact, the surface is on layer 0. When it creates it by default, it puts it on layer 0. Okay. When it creates it on layer 0, this is not in the assignment. Don't use layer 0. I would put the surface on a layer called C10. Okay, so this surface should be on a layer called not 0. By default, everything that gets created goes on layer 0. Put it on a layer called C10. Okay, that's not illustrated in the assignment. It's not good practice to put anything on 0. Make sure it's on C10. Okay, for the triangulated irregular network. So now you can see here again, right? If I push this to the back, right? Sometimes the triangles are exactly where you want them, and sometimes they're not, right? So this diagonal here is wrong. It should connect these two dots, not those two dots, right? So how do we get it to behave? If you've already added break lines, no problem, add more, but make sure they're proximity. Say okay, pick those break lines, and watch what happens. The cyan lines are going to adjust to connect the dots in the sequence that you see. Watch, hit enter, and now they're all on top. Right, so now the points are connected in sequence based on that line, right? And the line, it's still there, right? The break line's still there, right? But there is a triangle edge directly on top, right? And that's the purpose of the break line, to connect the dots in the sequence that makes sense. That's reality, right? So when you see triangulated irregular network, that's what's irregular. It may not be representative of reality. So it gives you these other tools, right? Let's add the possibility of defining break lines so that, you know, whatever triangulation is created, we can modify it to mimic reality a lot closer. Okay, so the assignment requires that. You have to import break lines. You have to create some break lines for the water course. Okay, the last thing to look at to create a surface is the boundary. Okay, now why are we talking about a boundary? Well, the boundary has to do with, if you look in the field here, right, you can kind of see the pattern of points, kind of how close they are together, right? I'm going to measure just by eye in here. This is approximately 20 meters. This is approximately 20 meters. They kind of walk the site every 20 meters, approximately, right? It's not a perfect grid, but that's kind of the density of points, every 20 meters, and maybe a little bit less here and there. When you look at the intersections, you can see these long, skinny triangles, right? A surface is created based on the relationship of the points. It tries to kind of shrink wrap it as much as possible on the edge. But if you have an irregular shape, right, a non-circular or square shape, you're going to get these long stretches. It creates a surface, but it's not real. There's not enough points there to define it, okay? So if you consider this layer here, which is called the T embankment layer, that's the limit of the data. So let me isolate that layer, right? The edge of the surface should be right here along these edges, right? This is really what the shape of the surface on the perimeter should look like, okay? But when you turn everything on, you'll see there are triangles outside that area. So we want to get rid of these triangles. There's two ways of doing it. One way is to give it a boundary definition. So that's the first thing I'm going to show you, okay? And I'm going to use that layer. I'm going to take this layer called T embankment. I'm going to make a copy. Now here's the technique. This is kind of a tip or a trick, okay? A process I developed. You can use it or not. One thing you can do is go all the way around and connect the dots, right? Just go all the way around and connect the dots. But we already have lines that connect the dots. They're called embankment, right? So what I'm going to do is this. I'm going to make a copy of all these. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to make a copy of these. I'm going to pick a point anywhere on the screen. Just click. And then I'm going to turn my ortho on. And I'm going to go this way 2,000 meters, 2 kilometers away. Okay? So now I have this stuff here. The next thing I'm going to do is I'm going to create a new layer, if it's not there, called boundary. It might be in the file already. There it is, boundary. I'm going to make it current. I'm going to turn it on, and there it is. Okay, so this should be on that layer, boundary. Remember, this is a copy. The original ones are still in its original spot. So I'm going to put it on a layer called boundary, right? So I made a copy of these 2,000 meters to the east, and I put them on this layer called boundary. Now I'm going to turn my OSNAP on and use the endpoint OSNAP, and I'm going to go to each intersection, and I'm going to draw a polyline across from this endpoint to this endpoint. Okay? And be careful, because sometimes, and I'll show you where there's some issues. See here, make sure you pick the end, not this, right? At a glance, you might miss it. Make sure you choose the proper endpoint and endpoint. Again, there's another one nearby here. Be careful, right? So just close it off. Go all the way around and draw a line across, closing all those intersection areas. When you get to here, do the last one here and leave one open. Okay, so you close them all except one. This is, again, my process. Polyline edit, right? PE for polyline edit. I'm going to pick one, and then I'm going to say J for join. J, enter, and then I'm just going to pick everything. And now it connects them all. It's one polyline. If I go to erase it, it's now one, not 8 or 7 or 6 or whatever. So now it's one polyline. To get that last line, I'm going to do another polyline edit. I'm going to pick it, and I'm going to use C for close. C, close, and it'll draw the last piece for you. So now you have a closed polyline. Okay, again, this is being recorded so you can review this technique at any time. Now I'm going to move this, move it, pick a point anywhere on screen, make sure your ortho is on, point to the west and go back 2,000 meters. Put it back exactly where it belongs. So there's the boundary for the site. Okay, I'm going to turn on all the layers. And I'm to that boundary now, make sure now all the T-dash layers are off. So let me try that again. I'm going to turn the surface display off for just a moment. Okay. So now that white line is exactly on top of the red lines that go all the way around. So if I go to erase this, it's going to count 2, right? The original red and now the white one that I created. Sometimes when you go to pick the boundary, which is supposed to go all the way around, it might actually only select the red thing underneath, and then you get a partial boundary. Okay, so be careful. The best thing to do is turn off all of the layers for the points and the break lines. So turn off all the T-dash layers and turn off all the P-dash layers, just so they're not in your face. Okay, so now all you have is everything but those points, right? And if I turn the surface back on to a standard setting, I'll see the surface. Okay? And there's that white line. This is what the boundary should be, but you can see there's a lot of triangles outside that area. So I'm going to say, hey, use this boundary. Anything outside, don't build anything. All right, so here we go. I'm going to go to not break lines, but boundaries. Right click, add. Just accept the defaults, say OK. And then when you pick that white line, it should do something. All right, so I'm going to pick that white line, and it shrink wraps it. See how you have a nice definition? All those long, skinny triangles are gone. And that's the purpose, or what a boundary can do for you. Okay? So 3 basic building blocks for a surface. There are others, but these are the main ones that I always work with. You need point data. They come from the groups. All the groups should be used as point data. Do not use the all points point group, right? Never use this. Just use all the D-dash stuff. Then you're going to add the break lines. Some of them you get for free from a DXF file. A couple there, 3 or 4, you have to draw your own for the watercourse. So make sure you draw them. Now, can you add break lines and then add more? Yes. So if you import the file, you can you can define the break lines. If you draw more, you can define more break lines, or you can draw them all and define them all at once. It doesn't matter, right? You can do as many as you like, one set or a series of sets, and then finally draw that boundary and define it. Okay, and then this is the almost the final version of the surface, right? That's the data for the surface. Points come from point groups, break lines, some provided, some you have to draw, and then finally the boundary, which you have to draw. Now there is another way of making sure that the boundary is exactly what it's supposed to be. Here's another technique. Let me get rid of this boundary. I'm going to delete it. The definition, right? The geometry is still there. And let me just make it red so it's easy to see. Another technique you can use, which I don't recommend unless it's the last resort, right? So let me show you here. So let me just make this red so you can see. Anything outside this red boundary should not be a triangle, right? So another thing you can do is delete the lines. You can actually edit the surface and manually clean up the edge. So you can do that under edits. So again, surfaces, existing, under definition, there's this thing called edits. If you define a boundary and there's still some triangles on the outside that you don't want, you can then manually go and delete the ones. So I'm going to right click here and delete line. This is a Civil 3D function for deleting a line on a surface. Okay, don't use AutoCAD delete, right? If I say erase this line, you're going to erase the surface. It's gone. Okay, you just want to edit the surface. So we go to existing surface, definition, edits, right click, and delete the line. Now, any line you touch, and you can use a crossing window, is gone. And you can go all the way around the site and delete the lines that are outside the red line and create the same effect. This is a little more time consuming, but you can have the same desired result, right? Just delete the stuff on the outside, using that boundary as a guide, right? Anything here, gone, right? So when I'm done going all the way around, it'll be exactly the same effect as what the boundary does. Takes a lot longer, it's a little more tedious, but that's an alternative. Okay? I sometimes use that technique instead of drawing the boundary, especially if the boundary lines aren't provided like in this one, but you don't have to. I prefer, again, not to do any of the edits, but to add the boundary, and then it shrink wraps the whole site. Now, when you do that, sometimes there's a couple of triangles that are misbehaving. Then, once you've applied the boundary, if there's still some that are outside, then I would, as a last resort, go and use the delete line command on the surface editing. And that's the surface, okay? Points, break lines, boundary. Those are the three fundamental things you'll always use to create a surface for the most part, okay? When you go to work and so on. Any questions so far? You can use your audio. Oh, as for the double lines on T watercourse layers, should I connect the ends? You don't have to. It's just it's the length that you're interested in, right? Not across, right? So just go down each side or go down the middle into one, and that's it. Right? What happens across is irrelevant. It's the length that's important. No, they don't have to be, as long as they're polylines, right? So when you bring the file in, you can explode it, but then once you have polylines, don't explode them. They have to be polylines. They can't be lines. Okay. All right, let's go. Keep going. Oops. All right, so let's keep going. Now, we're not done. Now we've given it all the data, right? Here's some points. Here's some break lines. Here's the boundary. I'm just going through a process, right? It doesn't matter what the points are. Doesn't matter what the break lines are. Doesn't matter what the boundary shape is. I'm just going through a process. The next part of the process is to check this for anomalies. What you want to do is make sure that there are no spikes on the surface. Okay, what do I mean by spikes? Well, when you look at the surface, it looks fine in 2D. But what I do is I click on it, I right click, and I use this command second from the bottom called Object Viewer. It's going to open up a new window. Okay, and if it's not full screen, you can make it full screen. It usually comes up small. Right, let me just show Usually it comes up like this. You can expand it. Okay? And now you see the surface kind of in a 3D. You can change the look. 3D hidden, wireframe. It looks a lot like the drawing. The one I use is conceptual. This kind of colors in all the triangles. Okay? But you can experiment with the different looks. Right? There's so many different things you can do. I usually use conceptual. Right? Sometimes realistic. But I like this one, conceptual. Okay, so now it kind of colors in all the triangles. You can start to see features now, right? You can see kind of the creek or river, especially that Y-shaped one. You can kind of see the one in here, that single line. It's not easy to see, but it's there. But this is looking down on the top. I'm going to click. This is left click, right? So I'm using my index finger. I'm just going to click, hold, and rotate. Watch what happens. And I'm going to zoom out, and I'm going to rotate. See how it looks like there's some really weird stuff going on? It almost looks like a table. See this stuff pointing down. There's some spikes going down, and then there's this huge spike going up. Everybody see that? Now, you wouldn't notice that if all you ever do is look down on the plan, right? It's hard to see in 2D. But as soon as you rotate it in 3D, oh my God, look at that. Stuff is kind of weird, right? What's going on? Well, now what you need to do is investigate why that's happening, okay? And what I've demonstrated in this drawing is two typical spikes that you're going to encounter. There are many things that can go wrong with a file, but these are two common spike issues that you'll encounter, okay? So we need to make sure that these spikes don't affect, because that long spike has a volume associated with it, and it's really going to throw your calculations off, okay? Same thing with the spikes down below, right? They look like table legs at the bottom, right? So how do we get rid of the spikes? How do we know what the spikes are, and why do they exist? There's two typical common spikes that you should be aware of, okay? So here's your education for dealing with this. The one thing I look at is, as I go to my points, okay, and I do this in all points, all the points, I want to just, I'm going to say edit so that I get a dialog box, but we're not going to change anything. So I'm going to edit the points, and I'm going to look at them in this dialog box. Okay, so let's see what's going on. So I have point number, easting, northing, and elevations. Okay, and you'll notice they're in order of point number. Well, because this is a database, you can actually click on the column and sort them biggest to smallest based on each column. So I'm going to go to the point elevation, and I'm going to sort them by elevation. There's a bunch of zeros. I'm going to do it again, and there's the highest elevation. Right? So from lowest to highest. If you look at the lowest elevations, there's a bunch at zero. Those were those spikes that were kind of those table legs going down. You'll notice there's zero elevation. And if you look at the description, they're all hydrants. Okay. Now, in this example, they're hydrants. There could be other features hydrants. I'm using hydrants. What happens with the hydrants is because the hydrant is high. Some surveyors, or most surveyors, put their survey equipment right on the top of the hydrant, okay, which is not the ground. All it does give you the northing and easting of the center of the hydrant. But the elevation of the top is now, you know, about 2 or 3 feet off the ground, depending on the hydrant type, right? So the northing and easting, the center position of the hydrant is significant. You want that to show in the map on the right spot. But the elevation of the top is actually not real, right? If you actually took the elevation of the top of the hydrant, you get a bunch of little pyramids everywhere you have a hydrant, right? The ground is below, and then right in the middle of the hydrant, it's high, about 2 or 3 feet higher. So because I don't want all these little spikes, which are still wrong, they're close to the ground, but they're always going to be above the ground by about 2 or 3 feet. I want the symbol, I want the point in the drawing, but I don't want to use the elevation of the top of the hydrant. So we artificially force it to 0 so that we can see, hey, they're way down. They don't belong on the surface. So one way of getting rid of these points, I don't want to delete them. That's one way, but I don't want to delete them. I want to know where my hydrants are. But at the same time, I don't want to use them to build my surface. So here's how we fix that problem. And you'll notice the next elevation in my case, and this is different for everybody, my case is 145. So I can go to the surface and say, hey, if the elevations are below 100, ignore them. Okay. Now you might have, in your case, you might have 90 or 80 or 60 or 100. Everybody's going to have different elevations. That's why you have different topos, 1 through 8. So sort them by elevation. And then whatever this number is, pick a number below it, way below it. Right? I'm going to use 100. Anything less than 100, do not use to build this surface. So here's how you do that. And this is outlined as well in the document on building a surface. Existing, click, go to properties of the surface, surface properties. And if you go to definition under build, you'll see exclude elevations less than, yes, turn that function on. And less than what? 100. Anything less than 100, don't use it. Don't delete the points, just don't use it for the surface build. So when I say OK, I rebuild the surface, they're no longer on this. Now the point's still there, but let's look at the surface now. If I click on the surface and I right click and I go to object viewer, when I turn this, all the ones below, remember all those table legs that were pointing down, they're all gone. So I've eliminated them from the surface build. Okay? So that's the technique. So you can ignore points near 0 by being below most of the data. That's exactly what I've done. Everything I typed in, yes, 100. is in the document. Now, the number 100 might be different for each topo. So you have to sort the points, go to edit points, don't change anything, but get this dialog box. Sort them by elevation. You'll see a bunch of zeros. Ignore everything below a number less than the one I've highlighted now, whatever yours is. They're different for every topo. Okay, so you have to decide what number to use. I could have used anything less than 10 and still done the same job. When I sort them again, I'll see here. So most of my points are, 170 to 145. So that's really my point data range. There's just one point that's way off. Maybe that should have been, some other number in range. It's so far out of whack. Maybe when they took that ground shot, instead of accepting what was in the data collector, they typed the number in and they typed it in wrong. So that's another one that's kind of off, right? Human error, typing in the elevation wrong. So when you have this point that's way out of range with respect to most of your project data, you can ignore it as well. So if I look at the next point, then, right, all these numbers are kind of near each other. If I look at this one, I'll ignore everything above 200, and it should get rid of that spike. So let me look at that. So I'm going to go to the surface, right click, surface properties, build, and now there's a function for greater than. Yes, turn this function on. Anything greater than 200, ignore it. Say apply, rebuild, okay, get rid of your points here. Click on the surface, right click, object viewer, and now when I turn it on its side, everything is in range. Okay, now is everything perfect? It's hard to tell, but at least the really ridiculous ones are out of the way, right? Some of them are done on purpose, like the hydrants. Some of them are just errors, way out of whack. Let's ignore them. You don't need to delete them. There might be something significant in the plan, but vertically they don't make sense to use. And that's as good as you're going to get. Okay? There's not much more you can do to this surface to make it perfect. Okay? This is as perfect as it can be based on the information we have and the techniques available. And that's your existing ground surface. At this point, if you were thinking about a company setting, somebody can start using this surface to design. In the meantime, you can continue working and create the presentation file, right? Look at the drawing required for assignment 1. But at this point, you can stop presentation, which is what this assignment is about next, versus design. You could start using this. So what we do after this point, when this surface is ready to this point, anything we do going forward now is not changing the surface geometry. We're just going to look at it in different ways, okay? And that's the styles that we're going to look at next. So a quick summary. Points from point groups. Break lines from given or created polylines. Boundary, and then check the surface for spikes. That's the last thing you can do to make this as perfect as possible. Okay, and that's how you build a surface. At this point here, the surface will no longer change. Okay, we'll look at it differently, but it won't change. So if you look at the information now, we've gone through create surface, and in here it tells you, import the break lines, create a surface, give it a name, go to the definitions, add the point groups. Make sure you choose just the point groups, and there might be some missing here. Isolate the T layers. I've given you extra instructions. Do not include sand, storm, and water. Okay, make sure those are off. Any T dash layers related to the surfaces. Add the break lines. Make sure you use proximity break lines. Select all the polylines. Add a boundary after you draw it. That's not shown, that technique. That's my hint to you, right? That 2 kilometers over and then 2 kilometers back. And then add the boundary. Go to surface properties and change the elevation, anything less than, anything greater than. What numbers to type here depends on the CSV file. So you need to check it, right? You have to see, sort the points from top to bottom or bottom to top and see below what number should you ignore, above what number should you ignore. So each of you have to figure that out yourself, okay? But that's all here. So that's a summary. Any questions about the surface build so far? I'm going to save this before I do something silly. Oh, and by the way, the layer for boundary, right? That boundary layer, right? That one that goes all the way around, I'm going to freeze it. Don't delete it. If you delete it from the drawing, then your surface boundary is gone. It has to stay in the drawing, right? So don't delete it. But if you don't want to see it, and you do not want to see it. It's not a ground feature. It's just for the surface build. Freeze the layer, right? You don't need to see it for it to be a boundary, right? You need to see it to be able to pick it as a boundary, but you don't need to see it in the drawing. So you should always freeze that layer, but never delete it. Otherwise the effect is gone. Okay, so the last PDF is surface styles and surface label styles. So when we look at a surface, right? When you're looking at the data, let me turn the surface off. Let me change the style to no display. And I'm going to turn on all my layers. Oops. Sorry, all the layers should be on. Oh, if you don't see the points, you have to regenerate the view sometimes. Okay, here we go. So all the points. So when you bring in the points, it's kind of hard to tell what the surface looks like. When you bring in the break lines, you get a better idea of what's what, right? Oh, there's roads and there's some streams and so on, so that helps. When you build a surface, it really gives you, it completes the picture, right? It connects the dots and colors in between on all the triangles, and it gives you an idea of what the surface looks like. And when you look at it in 3D, it's a really good view of what the ground looks like. Okay? And there's better ways of looking at it with styles. So when we look at the style called standard, it's just a bunch of triangle edges. Okay? And if we look at this in 3D, we get a sense of what this surface is starting to look like, right? You can see the streams and so on, right? But not a lot of detail. So points by themselves, it's hard to tell what's up, what's down, what's high ground, what's low ground. The lines fill in some of the information. But what we want to do now is create styles for the surface. So I'm not changing the surface. I'm just changing how we see the surface. Just like points have different marker styles and point labels have different styles, the surface has different styles. So if we go to settings, under surfaces, under surface styles, there should only be two. That was in the default I gave you. Always start with an existing style. So the standard style, click. Instead of editing, I'm going to make a copy. And I'm going to call this one contours. And then if I go to the contour settings, I can decide on what that geometry is going to be. So here's an example, contour interval. Well, I want to contour every 0.2 meters on the minor and every meter on the major, right? So I'm going to have a contour every meter, and then I'm going to chop it up by 0.2 in between. Okay, so a minor and a major contour interval. So you can choose these. So I've got settings. I want you to create a style. I've got different numbers. This is just an example. So there's the range. So if I go to the display tab now, I don't want to see the triangles anymore. I turn that off, but I do want to see the major and the minor contours. Turn those on. So I should see major contour, a green line on every full meter, and in between each green line, I should see 0.2, so 2, 4, 6, 8. I should see 4 brown lines, okay? And that's what this style will do. When I say OK, nothing happens. It still looks like that. Why? Because I just created the style. I'm not using it yet. So I go back to Prospector. I go to the surface called existing, right-click, surface property, and change the style. I don't want it to look like the standard one, just triangles. I now want it to look like the contour style. So now I'm just changing styles. Watch what happens on screen when I say OK. Remember, I turned the triangles off and I turned the contours on. And now it's a contour map. So you'll see the green one, if I ID this, is 162. The next green one, 163. The next green one, 164. So they're green on every meter. And then in between, 62.2, 62.4, 62.6, 62.8, and then we have the even meter again. Okay, so there we are. So that's the style, right? So you can change the interval, you can change the colors, you can change quite a bit, right? And now the contours, remember what contours represent, right? If you walk along the contour, it's a constant elevation. And then you can quickly see more information about the surface. For instance, when the contours are far apart, that's relatively flat. When the contours are close together, that's relatively steep, right? Contours close together are steep ground, contours further apart are flat ground. And that's another way of reading the surface. And then there are two distinct features that you want to be able to see. Remember, let's not look at the elevations. Let me turn the points off. Okay, I don't want to look at the numbers because that's a lot of numbers to analyze in your head. But I'll give you two quick tips on how to read contours. Or three quick tips. One is the density. So the more contours, the closer they're packed together, the steeper the ground is, right? So right here, right, this is where that stream is. You can see steep coming down and then going up. Okay, so it's steep on either side and low in the middle, so flat in the middle. So contours close together are steep, contours further apart are flat ground. When you're looking at a road, you can kind of see this arrowhead shape. See this arrowhead shape? Everybody see that? You see that arrowhead shape. Now, if you remember what a road looks like from highways, right? It looks like this, right? High in the middle, low on the sides, and you might have shoulders, right? This has shoulders, right? It's high in the middle and low on the edges. Well, if you look at the elevations, if the elevation of the, let's look at a road and plan very quickly. So this is the center line of road, and these are, sorry, this is the center line, these are the edges of pavement. If I look at a cross section, right, this elevation is higher than these two. And if the profile of the road is falling this way, then this elevation is lower than this elevation. Okay? So now, if this is higher than this, and this is higher than this, then the contour pattern should be something like this. Let me turn my O-snaps off. Clear. So if I have an elevation here, and I have an elevation here that's higher, the same is true here, right? This elevation is lower than this one. So then the contour map should look like this. This elevation, if we're going uphill this way, and we're going uphill this way, then this elevation will appear somewhere back here. And this elevation will appear somewhere back here. So the elevation from here to here to here is equal, right? And that's true along any road that falls this way. So that arrowhead pattern, they always point downhill. So when you look at these roads, even if you don't know the elevations, you can tell by the pattern. See this intersection? It's the highest elevation. It's falling away in all four directions. Okay? This one is steeper than this one, but they're all falling away from the intersection. And if you move along the road, you'll see that pattern. Oh, this one is the same. The elevation of the intersection is high, and it's all falling away. This is downhill in all directions. This one is steeper than this one, because these contours are closer together, these ones are further apart. And you can see where the contours point together, right? This is coming this way, this is coming that way. This is a low point on the road, the low profile. And you can see that all the way around. And if you come to here, you can see, hey, this is a high point on the road. It's falling to the north, it's falling to the south. This is a high point on the road. So without looking at the actual answers, the numbers from the points, you can tell what's uphill and what's downhill on the road. Okay, and that's one thing you want to learn about reading contours. Okay, so when you look at a road, the contours point downhill. Right? Here's another low point, right? Coming down, there's a low point through here, right? And imagine it connects to where the low point of the stream is coming out. So there's a crossing here where the road profile is low. If you look at a stream, whether you're looking at a V-notch, like this one here, or if you're looking at a trapezoidal bottom, it's low in the middle and high on the sides, the opposite of a road, right? It's low in the middle and high on the sides. So when you look at those contours, the contours on the road point downhill. Well, if you turn the shape upside down, the contours on a stream point uphill or upstream. So at a glance, you can tell which is upstream and which is downstream. So see here, see this pattern? You can kind of see this way, this way. The contours are pointing uphill or upstream. So the water actually flows in the opposite direction. Right? So if you know it's a stream, you can tell which way the water flows just by the pattern of the contours, right? And even if it's a flat bottom, you can see here, right? Generally speaking, this arrowhead shape is going upstream. So the flow is actually going this way. Right? So this is the low point of the stream. Right? You can see here again the contours, uphill, uphill, uphill. Okay? So these are two patterns you want to be mindful of. Let me clean up my drawing. Okay? These are two patterns you want to be mindful of, right? If you know it's a road, you can quickly tell what's downhill. So in this direction, south is downhill. And what's happening over here? Oh, here's a high point on the road, falling east and west. Here is, this is interesting. It's coming down to the intersection, and then in the other three directions, it's all downhill. So at a glance, I don't know what the elevations are, but I know which way is uphill and downhill on the road, and I know which way is upstream and downstream on the streams or the waterways. Okay, and that's a great way of reading the map. So when we used to show drawings, topographic information on a plan, we would generally show contours, because if you know how to read contours, you can visually see a 3D image. As a matter of fact, if you spend enough time doing this, you can look at the contours and actually see this shape in your mind's eye. Okay. Luckily, we have the software and the technology to do it, but there was a time where all you got was this on paper, and you would have to interpret the contours based on the ground features, which is uphill, which is downhill. Okay. So a contour map is a better way on paper of showing, and we still use a lot of paper for drawings. Okay. So what style should you use? Well, again, it's spelled out in the assignment. So in the assignment, it describes, these are your styles for labels, these are your group settings, so it tells you here, from tool space settings, create contours every half meter and 1 meter. Major 1 meter, minor half meter. I did major 1 meter, 0.2, minor, okay? And so on. So that's the style you want, okay? So don't do what I did, do what it says in the assignment. Okay, so then you have a style. Oh, you don't like that style? You can create a new one, or you can revise the one you have, right? So if you go back to settings under styles, you can create a standard copy of it, call it more contours 2, and give it a different name. Make sure you see contours, but you don't see triangles. And then go to contours and change the interval. I'm going to go every quarter meter and every 1 meter. Okay. The assignment is every half meter and 1 meter. So now I should say 3 contours in between the major, right? 3 in between the major contours. And I want to see just that, okay? Another thing is this style. If you look at it in plan, these are the settings. You can actually change it to model, which is 3D. In 3D, I want to see the triangles and the contours. So you can turn them on as well. So there's actually some subsettings for each style. If I'm looking at the plan in 2D, I only see the contours. If I look at it in 3D, I see the contours and the triangles. You have to have the triangles to see that shaded thing. Otherwise, you won't see it. Another thing I like to do, again, this is just information, I can actually go to my contours, the 3D geometry, and exaggerate them. I'm going to stretch it by 5 times. If I do that, I also have to do it to the triangles. I don't know why it doesn't have a global setting, but I'm going to stretch these 5 times. So I'm going to take my surface and stretch it in the vertical 5 times, right? I'm just going to do that. You don't have to do this, but I want you to see the effect. And then make sure that your contours are on, and then for the plan view, in this example, I want the triangles on as well. What's going to happen? Nothing, okay, until I swap the style. So if I look at this in 3D, the contours disappear because in the model, the section view, I'm not viewing them, right? I'm just viewing the triangles, right? And then in the plan view, I'm just viewing. So look at this style. This is the contours, the first one. The display is look at the contours in 2D, and in 3D, just the triangles. If I change this style, right, I do it here, click surface properties. Let's use the contours 2. So watch, the density of contours is going to change. There's going to be less brown ones, right? So now there's only 3, right? I go from a full meter to quarter, half, 3/4, right? 0.25, 0.5, 0.75, and then the next full meter. So I change the density of the contours, not the shape of the surface, just how many contours I see. And now when I click on here and I right click and I go to Object Viewer, I see contours in 2D. Watch what happens in 3D. I still see the contours. And it's vertically exaggerated. I stretched it 5 times. And now it's easy to see what the ground looks like. You can go from the contours on a piece of paper. If you see these contours in your mind's eye, you can actually interpret that and look at it in 3D. I can actually see this shape in my mind's eye. I've done this often enough that I can read contours and see this in 3D. But if you don't have that experience, this software really helps. And yeah, now you can see where the high ground is, where the low ground is, which way the waterways are flowing, what's uphill and downhill on a road, and so on. So that's a great visual aid on the data. This tells a much more complete and quick picture of what the ground looks like than just the points. And that's the whole purpose of creating contour maps. And that's why we want different styles that creates contour maps. Okay, so your assignment is to create a style of contour style. The last thing you need to do for this assignment is create label styles. So I want to know what the elevations are. Right? I got the general shape, but what is it really? So what we can do next is if you click on the surface and you go over to here, it automatically opens up this ribbon, right? When you click here, it goes to the ribbon called Tin Surface. And if you go over to here, Add Labels, you can add Contour Multiple. And now it's just like drawing a polyline. Anywhere this polyline crosses the surface, you're going to get labels of the elevation of the contour. So I'm just going to zoom in here. So I'm going to click here and I'm going to go across. And everywhere I cross the contour, it tells me what the elevation is. Okay. Oh, that's not a good spot. Okay. I'm gonna grip edit and I'm gonna move it and see how it's dynamic. You can stretch it right across the stripe. Any contour that's crossed will give you the elevation. Okay. Now on a drawing, you don't want to see the line. So if you type in CH for properties and you click on it, you can turn the visibility of the contour label line to false. And now you just have the labels. But if you want to edit that, you don't need to see it. You can click on the set, and now you get this temporary blue view, and you can move it around. And then when you hit escape, then you don't see it anymore. Again, click on the surface, go to Add Labels, go to Contour Multiple, and now it's drawing a polyline. Anywhere this line crosses a contour, you're going to get labels. See that? Everywhere it crosses, you're going to get labels. Okay, now, I wouldn't do something arbitrary like that, okay? The technique for labeling is something you want to do. You want to do something strategic, okay? Don't waste your time on the roads. We'll leave those. But internal to the site, inside the area bound by the roads, you want to label everything. You can almost think about the site being broken up into some spaces, right? If you go down the creek here and up the creek here and down this creek here, there's kind of 4 areas, right? 1, 2, 3, 4. So think about those as separate areas between the creek beds. Label the contours in there. And what you'd like to see is at least 1 label per contour, right? So I would go in here, add a label, multiple, and I would say, okay, I'm going to start here and I'm going to go down to here. And most of them are labeled. Maybe I'll label a few more down here. And the trick is to go downhill, right? Perpendicular to the contours, if you can. That's the best way to label them, right? And then for each one, and you can select similar and turn the visibility of the lines off once and for all of them. Okay? You shouldn't see the pattern if you can avoid it, right? The one thing you don't want to do is this, because then it's obvious. You want to try and follow the lie of the land, always go kind of perpendicular to the contours. So what you want to avoid is just doing this. This is lazy. Okay? So you don't want to just create labels like this. All right, just a grid pattern. Okay, I'll put label here, put label here, put label here. Don't do this. This is the lazy way of doing it. Okay? What you'd like to do is go downhill, perpendicular to the contours, perpendicular to the contours, perpendicular to the contours, perpendicular to the contours, as best you can. Right? Because even if you turn these off, right, the visibility of the lines, right, they're gone now, you can kind of still see the grid pattern, and it takes away from what the shape of the ground is. So if you kind of hug the contours by putting lines that are perpendicular, you don't take away from the view of the surface. I'm going to delete this. Look similar. Another thing you'll see is these labels, they're dynamic and they're annotated, right? So if you change the scale, see down here, change the scale to 1,000, they get bigger, right? The smaller the scale, the bigger the text has to be. And then your drawing turns into something else. Then it's more obvious. As a matter of fact, the drawing is going to be 1 to 1,000. So if you change this to 1 to 1,000, what you see here is what you're going to see in the viewport when you do your drawing setup. Okay, so now you see that grid pattern. So don't just go across, because that takes your eyes' attention away from the actual shape of the ground, right? The other stuff, if you follow the lie of the land, they kind of disappear into the landscape a little better, right? So always perpendicular. So concentrate on those areas. When you're looking at an area like this that's very dense, go to contour multiple, put those in perpendicular. Oops, too many. Click, contour multiple from here to here. You see there's too many, they're all on top of each other. What you can do for this one, not only turn the visibility of the line off, but you can turn the visibility of the minor contours, the brown ones, and just label the green ones, and then you can see a little better. So in the dense areas, you might want to do that. That's one technique, so only show the major. The other technique is to put this on the diagonal, and it spreads them apart a little better, then it's easier to see. So that's another technique. So no minor contours for this particular label, and put them on a skew. And then that helps kind of separate them. Now they're a little easier to read. So I'm only labeling the green ones, not the brown ones. All right, so this is the hard part. How many contour labels do you need? Well, here's the answer you're not going to like. You need enough, but not too many. So here's how I kind of mark this thing. When you print this as a PDF, which is what you have to submit besides your drawing, as soon as I look at it, if the first thing that catches my eye is the labels, if I see a lot of labels, if that's the first thing that catches my eye, you've got too many. And if I have to go squinting and searching for them, then you don't have enough. Okay? That's the only rule of thumb I can give you. This is kind of an artistic thing. It's hard to teach. You need some practice. So do what you can, create the labels, and that's really all I want you to do. But some will look better than others depending on these simple rules, right? Too many, if that's the first thing you see, not enough if you have to go searching for them, okay? And you have to make sure you have at least one label per major contour throughout the entire site, right? So this area. You can ignore the roads, leave the roads out, just the interior area, okay? And that's spelled out in the document. Right, where is it? From the menu, add the surface labels. Contour labels are not required on the perimeter roads, and so on. Right, and then it even gives you a style for the labels. I think it's already there as a standard. So if you want to know, you want to change the style of this label, you can go to settings. You can go to surface, not styles, but label styles under contour label, and this is the style for these. Right, so if I change this, edit the standard style. I would create a new one. Actually, let's create a new one. Copy the standard style. Call this 1D for 1 decimal place. I can go into there, right click, edit the style. Go into the elevation, surface elevation under the contents. This looks a lot like a point style. Click on this. Change this to 1 decimal place. That's what you want. You have to hit the arrow to make it happen. So this P2 turns into P1. Say OK, say OK. Nothing happens. Why? Because I didn't change the style. I'm not using it yet. So if I go to this line, I don't want to use the standard style. I want to use that new one, 1 decimal place. 1 decimal place. And now I've applied the style to the major and the minor contour. Okay. Now that 1 decimal place doesn't work, right? This is 2.5, not 0.2. This is 0.75, not 8. So this really doesn't apply, but that's how you can change the style settings for the label. You can change the font, the height, whatever you like. Okay, so I'll let you explore that. And that's it. And then you want to look at presentation. Okay, we'll look at presentation. This class is almost over. We'll look at presentation tomorrow. That will be the last thing you do, setting up your view, the scale, make sure you have a north arrow, stuff like that. Okay, I'll talk more about that tomorrow. So that's the final presentation. So for tomorrow, if you have time this evening, I would do your best to go through step 5 and 6. Create your surface styles and your surface label styles, and start labeling the surface. That's going to take a little bit of time. Okay? Tomorrow I'll show you the presentation, right, where we make use of this. If you're using my template, if you're using my template, then you should have a layout with a title block ready to go. And I'll show you how to cut the hole in paper space. That's a review. How to get the scale, how to put the north arrow, or talk about the north arrow and so on. Okay, so for now, so you should have done 0 with me in class, and then 1, 2, 3, 4 for homework up till today. And if you had that done, you should do 5 and 6 for homework for tomorrow, or at least get started on it. Tomorrow I'll show presentation only, and it won't take me the whole class, so we'll have time after class, during class for some questions, and then it's due on Friday. We'll talk about submitting it as well. Any questions? Okay. Pretty simple exercise to get started. We haven't even designed anything yet. We're just getting ready. This is really, in a design project, step 0, getting your existing condition ready for design. We won't start laying anything out until we see our subdivision layout, okay, and that's coming. I'll probably give access tomorrow for anybody who wants to work ahead, right? Any questions? Remember, you do have the ability to use your audio if you want to unmute. Okay, I enabled that today. Any questions? We got about 10 or 12 minutes before the end of class. Questions, comments? Okay, anybody else? Warren, are you still there? I remember you had some questions. We had some email exchanges earlier. Yeah, did everything work out? Okay, so everything's working now. Okay, good. I think you might have had issues with those warnings, right? To rebuild or update the groups. Okay, perfect. All right, so you know, I'm teaching the basics, but some of the tips and tricks that I give in class are useful. Can you show again how to change the point symbols? Yep. So to create the point marker, so I'll go back, share my screen again. Okay, so create point markers. So if we go back to tool space, under settings, it's under the point settings, under point styles. So how do you create point styles? I always start with the standard run, standard setting. I say edit, sorry, I say copy. Let me create the next one. So I give it a name. Let's call this one, is it sand maintenance hole? I forget the name. Let me just make sure I got it right for the assignment. So I want sand MH, right? So that's one of the ones I have to create. So go back to here, give it a name. I go to the marker. I'm going to use an AutoCAD block, which is what the instruction tells you to do. Right? AutoCAD block called sand MH. So I got to find that. It's usually near the end, sand MH. And how big is it? 1.5. 1.5. And I say apply, and I say OK. And now I have another style called sand MH. The label style for sanitary is down here. So it's going to tell me for sanitary maintenance hole, the label style is point number elevation description. So it should look like this style I just created. And it should be point number elevation description. Sorry. No, just go down each side, Warren. They don't need to connect. Just go down one edge and then go down the other edge. So then to create the group, now I go back to Prospector. I create a group. And I call it G-SAN-MH. MH. If you're in this group, what do you look like? Well, you look like a sanitary maintenance hole with point number elevation description. And how do you gain membership into the group? You have to go to the raw description SAN-MH. Now, if you don't want to type it in here, or you don't want to cut and paste it, which you can, right? This is what I do. It's going to be the T-dash down here. Or it's in the CSV file, right? San, p-san mh, that's the layer it's on, so it's t-san mh is the description. Right? I can't use p there. It's not going to look for the layer. It has to look for the description. So this t- comes from the CSV file. That's the description of the point. So if that's your description, you're a member of this group. If you're a member of this group, you look like this. Say OK, and there you are. Now, if we zoom in on any of these, zoom to, you should see the maintenance hole point. Point layer is off. And now the sanitary maintenance hole looks like that. That's the style for the maintenance hole. The storm one looks like a solid dot in the middle. Who was it? Michael, did that help? Sumitra, what's your question? You can use your audio. Turn your mute off. You should be able to talk to me.
Sir, for the label styles on the assignments for the visibility.
Contours, there's no choice. I've given you the style. It's in the assignment. Right? If you read the assignment, the style for the contours is given right here. Major 1 meter, minor ½ meter. You don't have a choice for this contour style. When it comes to the label, though, there's a bit of an artistic thing there. You have to be able to kind of view those areas that I pointed out. Put as many contours labels as you feel necessary. Okay. I noticed that in the 5th PDF, the point marker for are blue. Should the large color be
Hi, sir.
unless I tell you what color or line type to use, leave it alone. Don't change it. So if we go back to here, the last page, right? If I gave a layer name, make sure that the color and the line type match. If the layer name is not on this list, leave it alone, right? Just accept the defaults, which is typically white continuous, okay? So if I tell you to change something, go ahead and do that. If I don't tell you to change something, don't do anything, okay? When it comes to troubleshooting later, and some of you might have questions later, if I ask you to change something, I can see whether you did it or not. If I didn't ask you to change something and it's causing problems, I have no idea how to find that because I didn't ask you to do it. So if you start making changes on your own for whatever reason, it could cause a problem that I can't help you with. Okay. So if I asked you to change settings or change a style or create something, do it. If I didn't ask you to do something, don't do it. First of all, don't waste your time. And second of all, if the change affects your drawing that causes a problem that I can't figure out because I don't know where to look because I didn't tell you to do it, then it's a problem. You're going to have issues. I won't be able to help you. Okay, so only do what you're asked. Don't do anything more. Okay, and that saves time and problems later. Okay. All right. Any other questions? Can you show the point group part again? How to create the point group? Sure. Michael, try speaking. Turn your mute off. That was part of the experiment today. So I need to share my application again. Sorry. Now it's not letting me share. You can't see my screen, can you? Okay, I don't know why it's not working now. Oh, here we go. Okay, so here's AutoCAD. So how do you create a point group? Again, under tool space, so under tool space, under prospector, you go to point groups. You right click, create a new one, give it a name. It always starts with a G-storm MH. And then to gain membership in this group, include the raw description star.ncl and not G, but T. Remember, this is the text string in the description of the point that comes from the CSV file. So if that's your description, you're a member of this group. If you're a member of this group, you're going to look like a storm maintenance hole, which I don't have, right? So that's why you need the styles created first. So if it was storm, I would use storm, and then what do I want it to look like? Well, all three pieces. And then if you zoom in, you'll see the storm maintenance hole. It looks like the sanitary right now because I don't have that other style. Right? If you want to create that style, again, you can go to point style, make a copy of the standard one, give it a name. The marker is going to be, storm. The marker is going to be an AutoCAD point called storm manhole. 1.5 is the size, say apply, say OK. And then if you want to change it, then you go back to the group. Not a storm, not a sanitary, but a storm style. So that's what the storm looks like. So the sanitary looks like this cross-hatching and the storm looks like this dot. Again, follow the PDFs in order, right? Step 0, 1, 2, 3, 4. Before you create the groups, right? When I create a group, I want to select the styles. Well, you should create all the styles first. Otherwise, you can't do that step, right? So create all your styles first, then create your groups. And then you can apply the styles to the group, as opposed to creating the groups, then having to go back and create the styles, and then reassign everything to each group. Okay, spelling is important, right? If I go to the properties under include, if you misspell this, if you put a G or a P here, let's say I put a P here, none of the points have that description. If I say okay, that group is empty. See, there's no black dot there, right? This has points in it. This one does not because I misspelled the text string. This should be a T, not a P. All caps, it should match. I don't know how sensitive it is with the case, but I would put it exactly this. Matter of fact, like I said, I don't type this. As much as I can avoid it, I cut and paste it from the instructions. So when I say OK, now the points appear. It's part of the group, right? Anything with a raw description, T-STMMH is part of this group. And if you're in this group, this is what you look like, and so on. The last thing on the assignment, again, like I said, is is going to be the layer control, right? On the very last page of the assignment, it tells you which layers should be what color and what line type. All right. So I don't want to do anything else today. Tomorrow I'll look at the presentation. So once all your surface modeling is complete, once all your labels and styles for the surface are done, then I'll show you how to present it. Okay, maybe about the first half hour of class, I should be able to do the presentation and talk about what needs to be on the title block and so on. And then finally, we can have the rest of the time as a work period. Ask any final questions, okay? And then upload. Then you just have to upload to Blackboard before Friday at midnight. I do not believe the description was very clear in the instructions. Which description, Michael? Sorry. Sumitra, you can't use the true false visibility in the general tab. You have to go to the layout tab. Then you have access to the 3 different components. To type star description in the including raw text. Oh, okay. It wasn't clear. Okay. I hope it's clear now. Yeah, in the include tab. No, it's not necessary. You don't have to put the star in. The reason I put the star in is it's just a habit from work. If you have trees that are indexed, tree 1, tree 2, tree 3, tree 4, I usually put in star, tree, star, and then it'll capture all the trees, even though they have slightly different descriptions. So if things are indexed, and they do that sometimes with some features, right? Tree 1, tree 2, tree 3, well, star, tree, star will capture all the trees. Sometimes they label the maintenance holes, right? MH1, MH2, MH3. Well, I just want star, MH star. It's just a habit that I used to have from work, right? Catch basins are the same. Catch basin 1, catch basin 2, catch basin 3. Star, CB star, that all goes on one, all on one group. And you can use that as well for the description keys. Even though they have different descriptions, you can capture the common text string and put them all on one layer. But then the descriptions might be tree 1, tree 2, CB1, CB2. Sumitra, yes, general tab always has to be true. Go to the layout tab for the individual component settings for true or false. Visual, yeah, that's right. And I think that's clear in the PDF. Yeah, so it's star, T dash, whatever the name is, star. Right? So just take description right out of the CSV file and put an asterisk at the beginning and at the end. That's what I do. Again, they're not necessary because they're indexed. Okay, but I always put them. Okay, it looks like we're out of time. I'm going to stop recording. The recording should be available later.